Hello, welcome to my ray tracing engine demo. So 3 milestones. First one was to finish the ray tracing in a weekend implementation in the existing DXR engine. I just picked up where I left off last quarter. The second one was to complete the next series, the next ray tracing in a weekend series called Ray Tracing the Next Week. And then the third milestone was to take some of the new features I learned in ray tracing the next week and add them into the existing engine. So let's start with milestone 1. So where I left off was something that looked like this. This is the paper from last quarter. So I only had a few spheres, and the reason why I couldn't add lots of spheres, like how the book had it, was because I didn't have a sphere system. So that's what needed to be added for milestone 1. So this is the version that's in ray tracing in a weekend, and this is the one that I ended up with. So they're pretty similar. The parameters are slightly different. So the differences are in this one. So the book uses an array called world, which is just an array of spheres, and it uses that to iterate over to do the ray tracing. However, in the DXR engine, the HLSL has enums defined to keep track of setting graphics properties. So I just use that as well for the spheres. For material, I pulled albedo outside of material. That was more because I had conflicts adding DX structure into the material struct. So I moved it out to get things working, and then I didn't get back to moving it back in. So that's albedo, and then location's the same, radius is the same. And I'm going to just go through here to see if I forgot anything. And that looks okay. So yeah, so here's the book's version, and then there's my version. And so I can also just show a demo of that. And then just kind of look around. So we have the different materials, and then a bunch of small spheres, and then yeah. And then if we look at the book's way of generating the small spheres, I kind of just, since I had the architecture, I kind of just copied this over. So let me just close this and go to the random scene demo. And then, yeah, I have something similar right here. So that's milestone 1. Milestone 2 was doing the next book. So I'll just talk about each feature a little bit, and then whether or not I tried to do it in DXR. So this is the scene, the final scene from Ray Tracing the Next Week. And the new features are motion blur, which is this sphere over here. So this one, I add time parameters to ray, camera, and sphere, and then that gets used to track the camera shutter and where the center of the sphere is. So that creates the blur. And so this is kind of implemented in the DXR engine, but not really. The time systems are pretty different from each other because, one is real time and the other one is just a render. So just what I did instead was I just made a sphere move back and forth. So that's why I say that it's kind of implemented, but not really. Random volume hierarchy. So this is an optimization feature. Instead of doing the ray sphere intersection, a box gets created, and then we do a AABB intersection instead. So a BVH is essentially just a list of spheres, and as each sphere gets added to the list, there's a surrounding box function that gets calculated that's used to calculate the new box size. So that's kind of what this part is showing. It's just a BVH of all these little spheres here. I didn't do this at all. I kind of just, it was a lower priority on the list of things I wanted to add. So what I did instead was I just created it. I kind of used they use like a similar for loop in the ray tracing next weekend version to create the spheres, and then I kind of just did it and then kind of clamped them. So yeah, this is just kind of for looks. So that's BVH, and then next is textures. So this is the textures I've implemented in the DXR engine. Um, so Oh, okay. So I included this picture of the checker textures here because it's not in the final scene. Um, so the texture system defines UV coordinates. So in ray tracing, um, first we have to calculate the UV coordinates based on where the hit is, and then grab the color from a procedural defined texture, which is checkered. And then similarly, something happens with Perlin, except instead of checkers, there's this noise algorithm that's used to generate the texture instead. And then, so those are the two procedural textures. And then another feature was the image texture mapping, which is where this globe is from up here. Um, and there's lighting, which is up here. So that one I didn't do lighting because there was already lighting in the DX engine. Okay, and I think that's all I wanted to say on Milestone 2, because Milestone 2 and Milestone 3 kind of go together. I went back and forth between the two a lot because I had to use Milestone 2 as reference and then to figure out how to work into Milestone 3 and then, try to figure out which ones I can implement. So moving on to Milestone 3. So this is my version of the Milestone 2's final image. So I have the the non-BVH cube I talked about earlier, and then in the demo, the sphere is going to move back and forth. So that's like my version of moving sphere. And then this is Perlin, and then we have the checker textures because I didn't do the image from files, so I just used procedural textures instead. And then these three are from the previous demo. They included it, so I added to these three right here. Um, so let's go to each one. So for a moving sphere, let's go over to moving sphere. So this is the one where I'm just moving it back and forth. So that's done through taking in time as a parameter. And then I just have this in place function to translate the sphere based on time. And then this is just going to set it. So here's where the translation is defined, and then just move it based on the time. So if we go to update, let's see, what was it called? On update. So that's where the animation gets changed, the sphere moving time. That's just a counter. That's the time system that was used before. So I kind of just took a piece of that and then added in moving sphere. Next, we have okay. So something I forgot to mention earlier, one of the other differences with MS1 between the two systems are materials. So over here, the materials are pretty separated. And then based on which material the sphere has, that's the math that gets done to calculate what color we'll end up with. Um, so over here, I do have the material separated on on the CPU side, so I can create a material for each sphere. However, on the GPU side, they're all in the same closest hit shader, or the math is performed in the same place. Um, so that's where that was one of the differences. And then one of the there I could have separated it, but when I was trying to decide if I wanted to, go with having, because I guess what this is it's a, like essentially a super shader. And then when I was deciding between separating it out or keeping it together, so over here I have the pros and cons, and already working is a pretty big thing, and and making separating them meant that I would just, have to do setup again, and then it's one of those setups where a lot can go wrong, and then it's hard to figure out where the wrong part is. So that's a reason why I stuck with this part method. Um, so so the pros was it already works, and another pro is I can combine materials since everything's happening in the same place. So if we look at this one here, it's got checkers and it's metal. Uh, so that's that. And then the cons are it is harder to read and maintain. But like I said before, it sounds even harder to just uh, set up the separated parts. Not impossible, but I but this one was easier. Okay, so that's that. Next part, the random algorithms. So, so this at first started when I was trying to do fuzz. Fuzz is actually something that's from the first book that I didn't notice, I didn't implement yet until I was looking at this picture up here. And I was like, oh, this looks kind of soft. It's because it has fuzz. Um, so I have it right here. And what was it? Oh, for random. So what fuzz needed was access to a random function. In ray tracing in a weekend, it uses the random library from standard C++. However, that's not available on the HLSL side, so I either needed to just have random on the CPU side and pass it over, or figure out how to create the function on the HLSL side. I ended up doing the latter. Um, so, so I can show what that looks like. Let's see, I think it was over here. Ah, yeah. So then random. So I found different versions of random, and then I kind of just tried them out, and then it had different results, and I picked the one I liked more. So the way these work is you just put in a seed, and then you get a random value. So um, in order for it to be successful, you have to figure out what to pass in that would get a different seed each time. And I used the hit point of the array to get my random number. So ended up being useful to have these because the next in Perlin I needed access to random as well. Um, so for fuzz, let's see, was there anything else? So yeah, this is the book's version of how to create fuzz, and fuzz is just like this is like a fuzz factor. So I believe the lower it is, the fuzzier it is. Um, so I include the fuzz in my material. And then for random in-unit sphere, where's my version? Random in-unit sphere. So it'll create, where are we? Get sphere UV. Here it is, random in-unit sphere. So I pass in a seed so that I can get back a array that points to somewhere not at the sphere, or get a point that's not at the hip part of the sphere, but somewhere random within a unit. Um, so that's that part. And then that's fuzz. And so checkered, my checkered implementation is, let's see, just quickly. So this is the shader from last quarter, but it has a lot more in it now to account for textures. So for checkered, so I take the position and I convert it to UV, and then I pass the UV into this procedural function that will get my color for the checkers. And this part is just from the book. So get checkered color. Where are we? Get checkers. Let's do a search. So yeah, I think this part is the same. So yeah, that's checkers. Yeah, and they closely match. There's not too many differences for the checkered implementation. Next part is purlin, and yeah, that's the last one. So purlin is pretty similar to checkers in that I do the same UV calculation, but instead of this get checkers function, we do a get purlin, and get purlin. Maybe I didn't call it that. Let's see. Is it noise? Okay, yeah. So I created noise. I did some improvising here because the books version. Let me pull that up really quick. So the books version, it relies on random again. So we've got it generates permutations, and then uh, it's got an array, and then for arrays of random floats, it like creates them and jams them in there. And I did try to do this with HLSL at first, but I didn't like that. So I did a little improvising. Instead of, using the array, I created I used the random functions I already had. And then it took some tweaking to get some noise to actually show. Um, but I'm happy with what I have. And then similarly with um, actually the trilinear interpolation is the same. Yeah. Um, so yeah, my results were, and this is from the book too. This is one of the versions of Perlin from the book. And yeah, they're pretty similar. And because I have my super shader, you can see there's a little bit of the reflection in it here. So that's milestone 3. And then before I forget, let's show that demo too. Oops, not 3. Demo 3 is, I'll show that one really briefly too, but it's something I just started but ran out of time. Oh. Okay, so here we go. There's the moving sphere, there's the blocks or the cubospheres I mentioned earlier, and then there's Perlin. fuzz, and then over here we have the checker texture, and then textured with metal, and then I'm just going back over here to show the fuzz. So here's the three from last quarter, and then the fuzzy one. So it's still a little reflective, but not that reflective. So yeah, that's a demo. Milestone 3, or I mean demo 3. So the original DXR demo I had these objects called meta balls, which I thought looked cool. So this is a meta ball with the metal shader, and then I turned on textures for it. And then I was going to create like one of each with the different shaders I had, but I didn't do that yet. So that's just why demo 3 is there. Yeah. And let's see, did I have any? No, that's the end. So thank you.